now turn to Rohit to share some of his thoughts as a technology company provider who's seen global as well as India, I guess, experience. Do you have a PPT? Request you also to focus on a few key points to the extent possible.
Thanks, Dr. Tongia. The 5-minute challenge is actually a lot to keep up with. Yeah, but I'll try to,
to the extent,
stick to that.
Yeah,
yes.
To the extent.
So last year, I mean, when I came here, my whole theme was to try and pitch more and more. When everyone was talking about smart meters, I was trying to talk about how do we engage customers into the whole utilities business. Now, this year, it's very heartening to know that everyone is talking about that now. But now we have moved on to newer problem where what we are seeing from our Oracle's perspective is a customer-centric grid. I mean, it's not really completely owned by utilities anymore. So I'll try to put some highlights from Oracle's thought process as to what we think about it and how we see utilities are transforming to the need of the hour here. There are 3 major drivers that will change utilities of the future, which definitely is not going to look like the same as today. Decarbonization is one, of course. The generation of data on the edge of the grid particularly is another one where one needs to use a lot of data to make smarter decisions. And decentralization, of course. Utilities that have owned all the assets and all the generation plants and everything, that is moving away. I mean, we in future probably we wouldn't have it. One of the Gartner studies says that in future, say by 2025 or 2030, the largest utility in the world wouldn't own a single asset, much like Uber, right? I mean, they would be more like an energy service provider. So taking these points beyond the regular, I mean, I just try to collect some data about India. I took these data from Niti Aayog, but then I think this was proven wrong yesterday by Energy Secretary's speech, where these targets that were set, say, 2-3 years ago are already, I mean, outdated. We are already around 78 gigawatt power in renewables, and then we'll move around some 270 by 2022 possibly. So that emphasizes the need for the change all the more, right? And this is the worldwide picture. The whole revolution on renewables is being led by India, China, and US. So I wouldn't go into detail because all of you have seen these figures so many times. Now, a lot of things are happening on the edge of the grid, and we see the data that are being generated. In recent years, with AMI deployment, it goes to some level which is like 600 terabytes. And then now, with all the devices that are getting added, and DERs and then sensors and whatnot, it is likely to increase even more exponentially even in coming years. Now, what does that do? I mean, what does that do is that, there are so many things. Utilities are essentially, they are coming up to an idea of a platform-based approach in terms of managing whatever is happening, a lot of activity that is happening on the edge of the grid. So what we call it as a platform-based approach, where operational technologies and information technologies and consumer technologies comes together, and people are able to leverage data being generated from various sources together to make smarter decisions, to make judgments about the business, how to carry on, and everything. So it cannot remain siloed anymore. That's what we're saying here. One of the example, let's see, the best utility in today's world is not using more than, say, what we are showing here, more than 10 to 12% of their data that are being generated. We have talked to many utilities in US where people are throwing data away because they don't have storage space in their current infrastructure. They have to move beyond that and then be able to store data to generate a lot of insights. Now, all that become more important. Again, coming back to the same point where we are seeing a lot of actions on the edge of the grid. Earlier, we used to have unidirectional networks. Now we are seeing bidirectional flows coming in the network. How do we manage that? There's no current systems are not designed to be able to do that. We do not own. We are going to a model where we don't own more and more generation capacities, and these kind of things. A lot of action are happening on the edge of the grid here on the consumer side. This is the area, the house that you see here. So far in past, utilities have never worried about what happens there. But now we have to worry about that only, because whatever happens there will impact your ability to optimize and manage your grid, manage your own grid, right? So overall, there has to be some software intervention, technology solution that helps you make your energy supply and demand decisions which are customer driven. You need to have deep visibility into your resources on the grid, and some of these resources are not really on your grid, so to say, these days, because they lie outside that, and we'll talk about what is that. And then some real-time awareness about asset performance. My colleague Ramarao talked about AI-enabled asset failure prediction. You should know what is going to fail when, and all those kind of things. And then your response to those events needs to be more agile. Now, it's very simple. Integrating DERs into the network. I mean, our approach, and we have been working with a lot of modern utilities in US. San Diego is one example. You collect all the data about customer DERs that are in the network. You model every DER in terms of aggregated actual load and with weather data, day of the week, and so on. And then based on that, and then you sort of generate profiles, output profiles. You extrapolate and then predict how much energy for next 1 year it will generate, or next 24 hours it will generate, and you do that every 15 minutes. You redo that every 15 minutes, right? And then you make smarter decisions about managing your grid. And last but not the least, you engage your customers who are now what? They are prosumers now. They are producing power, they are consuming power. So you involve them as well. You give them insights that what kind of maintenance they need to run on their DRs, and what kind of you even connect them with the service providers and so on. So that all that proactively needs to happen through one system. New network management system, or new ADMS that we call it, needs to be able to store all these types of DR profiles. For wind PV, it is very complex. Battery, gas, hydro, it's relatively easier from our experience. For wind and PV, I mean, you need to be able to extrapolate with weather, time of the day, and then every 15 minutes, as I said, you redo the generation forecast. This is one example of three-dimensional load and DR output profile based on temperature, time of the day, weather, weekend, or seasonal peaks, and so on. And all that is done automatically using deep learning techniques, using all the data that comes to you. You don't need, and there's no manual step anywhere here. Another dimension to the topic of DER integration into traditional grid. As I said, there is a lot of action in the area of the grid where so far we have not worried about. We don't worry about what is happening beyond transformer, what is happening after 11 kV to 220 volt, right? We don't worry about that. But now most of the action is happening there itself. So low voltage network management has become the key aspect of it. You need the full and deep visibility into complex mesh network. And another aspect to that is active NMS concept, where you should be able to take smarter decisions, preempting something going to happen, and then you should be able to deal with it. You should have response profiles stored in your system, that if this happens, this is the standard response, and then that response should automatically get enriched from historical data or whatever happens live. it should learn on its own, and then it should continue to deal with that. So that kind of an active network management system concept we need to build in the traditional network management system applications. And yes, whatever I talk that involves machine learning, that involves deep learning techniques. So some of these examples here are like, you are able to predict storm damage, and then thereby you are able to deploy your teams in the outage events effectively. One of the latest thing that we did in our application is that you are able to detect an EV at a customer location. You don't need a customer to tell you that I have bought an EV. You will detect it yourself, and then you just manage it thereby. And then we talked about it, granular load and DR forecast, um, and accurate tracking and longer term forecast, all these things using machine learning analytics. Overall, what we are saying is that traditional
If I could ask
operational, sorry.
to bring it towards a concluding thoughts, please.
Yeah, I'm just concluding.
Thank you.
So the OT, the customer technologies, and IT needs to come together to sort of make a one holistic system for a utility to be able to deal with this great challenge that we all are facing now. So I'll leave with this question, that how we are going to deal with it. That's all I had for today. Yeah.
Thank you.
Yeah. Thank you.
Thank you, and thank you also for compressing it.